Hi, welcome back to Leetcode. So in this video, I am going to discuss the second problem from today's weekly contest, that is design event manager. So the problem is that you are given an initial list of events where each event has a unique event ID and a priority. So implement the event manager class. So you actually have a class event manager. Okay. And there are three functions actually we actually have inside this class, that actually event manager one. This is actually the constructor, or actually we have actually list of events initializes the manager with the given events, where events are actually kind of pair actually 2D. So first is the event ID, what is the ID of the current event and what is the priority for that. Okay, then we actually have another function that is update priority. Okay, it takes actually two argument, one is the event ID and this is second is the new priority. So updates the priority of the active event with ID event ID to new priority. That means we actually have suppose during the constructor, when it's calling the constructor, suppose this is our class name ABC. So actually got him, suppose priority event ID is 0 and priority is suppose 2. Okay, next I got event ID is 1, priority is 3. Next is event ID is 2, priority is suppose 5. Okay, so I actually have 3 events. Okay, so I actually initialize some data structure. Okay, so there actually I have stored that, okay, for this 0 event ID 0 the priority is 2, for this event ID 1 the priority is 3, for event ID 2 the priority is 5. Okay, now what I will do, I will call a update priorities function. This function what will take, it will take one event ID and new priority. Okay, so what it will do, it will update something I got. I have received the event ID as 1 and new priority as 10. Okay, so what we'll do, we'll actually modify this data structure that current priority for this event ID 1 is not 3, it is now 10. Clear? So we can call this function any number of times, so that's why it can actually modify. So it is possible that suppose first function I am calling this update priority with for event ID 1 priority as 10. Next again I am calling the same function update priority, event ID is same, now the priority is suppose 12. Even I can also decrease this, that previously it was 12, now it is 5. Okay, we can do that. So now this is the second function, update priority. It is clear that what this function actually does. Next is poll highest. So what is the function, indicates that removes and return the event ID of the active event with the highest priority. Okay, so that means we have to return the event ID which actually have the highest priority. Okay, if multiple active events have the same priority, return the smallest event ID among them. If there are no active events, return -1. Okay, that means suppose poll highest. Okay, so suppose you actually have this data structure, this information that for event ID 0 the priority is suppose 2, for event ID 1 the priority is suppose 5, for event ID 2 the priority is suppose 12. So if I call this function poll highest, it what it can return. First of all I have to check that what is actually the highest priority actually I have. What is the highest priority? That is 12. So any conflict, that means we can actually have that multiple events actually have the same priority, same highest priority. Okay, but here actually only one event actually have the highest priority. Okay, so that time we have to return this 2. Okay, so we'll return 2, and also we have to remove this data. Okay, next time if I call this poll highest, okay, so what I'll do, so I'll first calculate what is the highest priority. So what is the maximum priority actually I have, that is 5. Okay, what is the event ID for that priority is 1. Okay, I'll return 1 and I'll remove this. Okay, if I next time call this function poll highest, it will, this data will not be available. Okay, now next situation is when actually a conflict, multiple events are the same priority, then I have to return the minimum event ID. Okay, suppose actually for 0 we actually have event priority as 2, for 1 the priority is suppose 5, for 2 the event priority is 12. Okay, now you actually have another event ID that suppose is 3 and priority is again 12. Okay, Next I have again event ID is 4 and again actually 12. Okay, so if I call this poll highest, what is it will return? First of all, I have to check what is the highest priority actually I have. So what is the maximum priority actually I have? That is 12. Correct, 12. Okay, this is clear. But before returning this return event ID 4, I have to check that is there any multiple events will have the same priority or not? Yes, 2 event ID 2 also have the same priority of 12. Event ID 3 also have the same priority as 12 and 4. Now out of these 3 events, what is the minimum event ID actually I have? That is 2. So I'll return true, 2, not true, sorry. So, and after that I'll remove this data. Okay, next thing, if I call this function again poll highest, so what is the maximum priority I have? That is 12, still 12. Okay, before returning this 4, I have to check that is there any multiple events of the same priority? Yes, 3 also have the same priority and 4 also have the same priority. Okay, but what is the minimum priority minimum event ID? That is 3. So our answer will be 3. Clear? And I'll remove this from our information. Clear? Next time, if I call this poll highest function again, so what actually I'll see? What is the maximum priority I actually have? That is 12. Okay, and do I actually have any another event that actually have the same priority? No, this is the only event that actually have the highest priority. So our answer will be 4, and I'll remove this. This is clear how to actually handle this. Now we have to follow the just brute force, you can think, or not brute force, just you have to think how actually we can actually store the data and how can easily retrieve the data. Okay, so you can see that poll highest, we have to somehow retrieve the maximum priority, right? And we have, if we have the same high maximum priority if for the multiple events, then I have to store the return the minimum event ID. So if I somehow store the data in this order, then actually we can easily find out what is our answer will be. Clear? So first of all, I will sort according to the maximum priority. So suppose we actually have, so there are two pair, one is the priority, another is the ID. Clear? So if so I actually have two events, suppose, so priority 1 and ID 1. Okay, and priority 2, ID 2. How actually I'll sort this value? So I'll store that if P1 is greater than P2, then obviously this will be stored first. Suppose this is A, this is B. So A will be stored first and then B. This will be our sorted. If I actually sort the array, so it will look like this. First it will be A, then B. Clear? Then the next condition is that suppose if for such some pairs, we actually found that first priority is same, P1 equals to P2. Then actually how will you sort this? I will sort according to minimum event ID will be placed at the front or at the first, correct? So that means I will sort that ID1 less than ID2. Okay, so if ID1 less than ID2, then our output will be A comma B. Else suppose I found that ID1 is greater than ID2, suppose, then actually our output will be B comma A. This is clear how actually our sorted output will look like this. So if I sort the array according to this condition, what will happen that I will store the value in a sorted order, that maximum priority will be stored at the front. Okay, P1, P2, P3. If somehow actually suppose same priority, then actually minimum event ID will be at the front. Clear? So now actually if I call this function poll highest, I will return this value from here at the front, right? But this is actually if we cannot update the value, then actually this will work. Otherwise what will happen that every time, because here actually in this case what actually we can do, we can actually update the priority of any event or any time, correct? So that's why before returning any value from this poll highest function, we have to again sort every time, that it may possible that now we have changed the priority, so our array, whatever the previous array actually look like this, that is no longer actually valid now. So that's why every time if we find out the value result from this poll hash function, we have to sort the array. So that will take n log n, right? Why n log n? Because if there are n events and our array length will be n, and to sort that it will take, in the average case is actually it will be n log n. Clear? But we can optimize this. How? So we don't need to actually sort every time. So if actually dynamic, this is kind of dynamic array because our array can be changed. So we can actually use here actually priority queue, or we can say this is heap. Correct? So heap, what should you store? I actually have two things. One is the first is the priority, and then it will be the ID of the event. Correct? I store this information. So if I sort the heap according to this condition, we can actually customize the condition for heap, any heap, right? So that's why we can customize the sorting condition, that this will be our condition to sort the elements inside this heap. Correct? So condition will be same, that if our first uh, element, that is the priority, it is greater than the next element, then it will be actually placed at the top of the heap. And if the priority is same, then it will sort that according to the condition is that ID, if the ID of the first element is smaller than the ID of the second element, then the first element will be placed at the top of the second element. Correct? So we'll sort according to this. Now we need to do one more thing. Why? You can say that suppose update the priority of the active, so we can actually update the priority from this function update priority. Now what will happen, that suppose initially we created this priority queue or heap during the constructor calling. Okay, no, constructor creation. So what will happen, suppose for this example, let's take the example 5727 okay. So I have created this I've created one heap from these three events. Okay, so according to the first priority is 7, okay, and the maximum minimum event ID is 2, so it will be at the top. Next is suppose 5 again 7 5, next is 4 9, okay. So you can say that we have sorted according to this condition what actually we want to store. The first is that we'll store what is the maximum priority life, that will be stored at the front, right? And if we have the same priority, here you can see that we have the same priority, 7 and 7 both actually have the same priority, then you store whatever the minimum event actually have, that will be stored at the front. So you can see that 2 is actually present at the top of that. Correct? Now suppose we have called this function update function. So suppose for event, let's take this example, update history from 9 to 7. That means this data, this information is no longer valid. But can I actually remove this? We can remove, but this will not actually efficient, because again we have to iterate the whole heap, entire heap, then actually remove the whatever data actually we want to modify. That will not best, right? So what actually we'll do, we'll actually actually store this into this heap. We will not remove this, but we will store the new data into this heap. So we'll store 7. So this will store here 7 9. Okay, yes, we have 4 information, but this is actually no longer valid. So when actually you are returning the answer poll hash function, from this poll hash function, that time we would need to check that this data is still actually valid or not. Have we modified this information, or this is still actually valid? So how actually we can identify this? So if we store a map, so map, what is to store that what is the event ID and what is the current or updated priority. Okay, so how actually it will actually help me in this poll hash function to validate that this data is still actually valid or not. So you can see that first of all, suppose first of all calling this poll hash function. So I'll actually get this information. Okay, so our map is still for this event ID 2 our priority is still 7, and for event ID 5 it is still 7, and for event ID 9 it is now 7. Okay, this is clear. This is updated map. Actually, you can see that this is the updated priority of each event ID. Okay, now you can see that first of all I will get this information that this is the priority 7 and event ID is 2. So I'll check this map. Okay, this is still 7, so this is actually valid. So our answer will be 2. Clear? And now this will be removed. Correct? They mentioned that whenever returning any result, that time we'll remove the information also. This is no longer valid. Okay, next again I'm calling this poll hash function. I'll get this information 7, 5. Okay, so I'll check this from this map. Okay, for this 5, what is the current priority? That is 7. Okay, this is equals to this 7, so this is still valid. So what we'll do, I'll actually, our answer will be now 5, and this will be removed. Okay, now actually this heap will contain these two elements. Okay, again I'm calling this poll hash function. So I'll actually get this information 7, 9. 7 indicates the priority and 9 is the event ID. Okay, so now I'll check this 9, 7. Okay, so I'll check for the event ID 9, what is the current priority? That is 7, and this is same. Yes, this is same. So this is actually still valid answer, valid information. So our answer will be 9. Okay, and this will be now removed. Next, if I call this poll hash function, this is actually 4, 9. So if I check the map, I'll see that okay, this is not equal to 4. Correct? This priority I'm saying 4, but current updated priority is 7. So that means this is no longer a valid data. So I'll just remove this, and our answer will be -1 for that, because there is no valid data actually I have, no valid event actually I have, active event actually I have. So that's why they mentioned that if there is no active event, that time return -1. Clear? So if our heap size is 0, or we have not found any answer after checking all the elements, because all the actually events are now no longer actually active. Okay, no longer is valid information. So that time, after removing all of the data, I'll return -1 by default. Correct? I hope this is clear. I actually use a map to actually validate that this information is still valid or not. Otherwise, what will we have to do to actually make the synchronized our heap as synchronized heap? So when actually I am updating the data, so that time what I will do, I have to iterate the heap, and I will see that this data I am trying to modify. So if this is the event ID same, that time we'll remove first, and then actually we insert the updated data into the heap again. But to optimize that, what we'll do, we will not do any operation that time during the actual update the priority. So that time we'll just actually insert the new updated value into the heap. But during whenever returning any answer from this poll hash function, we have to check that this data is still validated data or not. So that time how actually validate this? We actually check this from this map. So this map actually contains this for this ID, what is the current updated priority. So if the priority of this ID still equals to same as the data present at the heap, so that time this will be your answer. Otherwise this is no longer a valid data, so I'll go to the next data. So if there is no data, our heap is size is 0. We have already consumed all the elements. That time our answer will be -1. This is clear. I hope this actually explained from in detail actually. So I'll actually use a map, and one is the priority queue or heap. You can say that max heap with some condition that if the priority is same, maximum priority is same for the multiple events, that time will sort according to the minimum events ID. Clear? So if you have any doubt, any suggestion, you will comment on that. Now go to the code. So first of all, I will take one priority queue or heap that actually stored a pair. First element of this pair will be the priority of the event, current event, and what is the event ID. Okay, and this is the sorting function for this priority queue. So you can see that I'll take two elements. One is the one pair, first pair is the A, and the next pair is B. So if the priority of the first element is already less than the second priority of the second element, that time return true. Else if the priority of the both of the elements is same, that time I will sort according to the minimum of the event ID. So that's why I'll check that if the event ID of the first element is greater than the event ID of the second element of B, so that time return true. We all know that we have to actually return the opposite thing for the in case you want to sort anything in the heap for C++. Otherwise return false. That means this is already sorted. Okay. So that's why. And also next data structure we need, that is the map, unordered map. So here actually we will store what against each event ID. I'll store what is the updated priority. Okay. So this map will store that. So you can see that I will just during the constructor calling, I am actually passing the events initial list. So it may be empty or it may actually have some data. So if I'll actually iterate for each event, then I'll check, I'll store into the priority queue. First is the priority and the second is the event ID. Okay. And also in the map also store this, because this is the initial priority value for the each event ID. So that's why this I0 indicates the event ID and I1 indicates the priority of that. Got it? Now actually second function is that update priority. So this function actually we can actually update the value. So I'll check that this event ID is still actually present or not. So if it is present, that means this is actually still active event. If it is not present in the map, that means this is no longer active. So they mention that if it has been removed at least once by the poll hash function, that means this event ID is no longer valid. So that's why when actually I call this function poll hash, and if I found any valid answer, so I would also remove the data from the map also. Anyway, I have to remove from the heap and also I have to remove from the map. So to check that this is still a valid or active event or not. So that's why map.find, I'll check that this event ID is still actually valid or not. So if it is valid, that means it will be present in the map. So that time I actually update the data with the new priority. So for this MP of current event ID with the new priority. Got it? So this will be modified to the map. Now also store this current updated value into this heap also. So priority queue dot push the new priority and the event ID. Still actually have the old value, old priority. We still actually have that value. Maybe actually have, suppose in the worst case, we actually have that value also in the heap. Sorry. Clear? Next is that here actually you can say that you can observe one thing, that we are not updating the heap. Means we are not actually removing the old priority with this current event ID. Clear? So to actually save the actual time here. Now actually this poll hash function, what will do? I'll actually iterate that our still actually a priority is still actually some element. If it is already empty, that means return -1. If empty means what? We do not have any active events, that time return -1. They mention that if there are no active events, return -1. Okay. So in the current, I will get the top or the maximum value present in the heap. So first of all, remove that. Anyway, it may be valid data, maybe invalid data. So anyway, first of all, remove that from the priority queue. Now I have to check that this is still a valid data or not. If it is valid data, that time I have to return the answer. Else I'll go to the next data, right? So that's why how to check that this is valid data. So I'll check that if this current event ID, current.second, what is the priority actually I have into the map? If it is not equal to the same, whatever the priority present in this heap, current.first, this indicates the current priority, and this from this map I will get the what is the updated or the newest, you can say newest priority. So if it is not equal, that times continue, go to the next element, try for the next possible answer. If it is equal, that means this is a valid answer. So first of all, remove from the map. Why should I have to remove that? To handle that this is actually no longer a valid answer. So if I remove from this map, and if I again actually trying to update this value, actually this if condition will be false, we cannot actually answer this value, we cannot update this. Clear? So first of all, remove from this map and return this current event ID, because anyways this poll hash function return the event ID which actually have the highest priority. If we have the same priority, same hash priority of for multiple events, I'll return the minimum value. So this current.second indicates the event ID which actually have the highest priority. Got it? Return that. Clear? And by default return -1 if our priority key or heap is empty, that means there is no longer actually active events till I have return -1. I hope this is clear. So I have shared this code in the description. You can check that, and you have any doubt, any suggestion, you can comment that. And if you like the explanation, please like the video. And if you're not a subscribe, please subscribe channel. It motivates me to create actually more content on this. Thank you. Bye bye. See you in the next video.